Hi everyone, welcome back. I hope you have a good break. So today is Monday. Yep, we are behind schedule. So today we will continue on 9.3. So today you have homework 6 about 9.1 and 9.2 due. Okay, and you also have quiz 3. So how are you doing on your homework? Good. Okay.
I've
So
been playing catch up, so
yeah, please do that this week. Okay, because I want you to do well on the second exam. When is the second exam?
next week.
Next week, Monday, and it covers chapter 8, 9.1, and 9.2. Have you started working on the practice exam yet? No. Okay. So I hope to see you more often this week in my office hours. Okay? Or if you are not available during my office hours, please email me. We can meet in the evening. We can go to Tech Live together. Yes. And if you plan to come to see me in my office, please email me as well because I have some meetings. So I can make it. Ooh, not here. Where's my Oh, okay. So my Outlook schedule. Yes, I have like meetings in the afternoon. So I strongly recommend you to like email me and tell me what time you wanna come. So then I can make sure I'm in my office. Like today. Today I'm free from 11 to 1:50. So feel free to bring your laptop and do your homework outside of my office. And when you have questions, you can ask me right away. Mhm. And also, yeah, Wednesday and Friday, I have the time from 11 to 1:50. Did you receive my email about the study session on Friday? Yes. So, yeah, you can also ask me questions there. But I hope that is not your first time to do your practice exam. I hope you do your practice exam 2 or 3 times, okay? So do it earlier and then ask me questions and also make sure you understand every problem on your homework, notes, and practice exams. And then, yeah, come to do the practice exam again. Okay, so that's the plan. All right. So let's see. Okay. Do you remember the concept map? Yeah, you can use the concept map to study. Your exam 3 is about chapter 8 and 9.1 and 9.2. And then sorry, did I say exam 3? No, I mean exam 2 is about chapter 8, 9.1 and 9.2. Exam 3 is going to be 9.3, 4, 5, 6. Okay? Um, so our exam is next week, Monday, right? I have a class before us. They also have exams. So if you want to take your exam earlier, feel free to come early to start early. Okay? So they'll be taking exams. Just come in, find a seat, and I will give you the exams. Okay. All right. So last time we talked about maxima and minima. And remember, critical point is where the partial derivatives, the first partial derivatives equal to 0. Okay, everybody? That's the critical point. And then how do we know whether that critical point is a maximum or minimum? We look at the Hessian matrix. D is the determinant of the Hessian matrix. If you haven't learned determinant, don't worry about it. E is simply fxx times fyy minus fxy squared. Uh-huh. And if D is positive and fxx is positive, remember, second derivative is positive, it means it's concave up. Then this is a local mean, right? If D is positive, but fxx is negative, it also means that fyy is negative. So concave down. This is a local max, right, everybody? If D is negative, which means some direction concave up, some direction concave down, so this is a saddle point. Okay? If D is 0, this is inconclusive. You need to put more points around the points, and then you draw the graph to decide whether it's a local mass or local mean. All right. But hopefully, all the examples and all the questions in your homework or exam, that you can tell whether it's a saddle point, max or min. Okay. And yeah, you're gonna solve system of equations. Think about the substitution method. You use substitution methods if you see one of the equation, the x power or the y power is 1. Because in that case, you can solve for the x in terms of y, or you solve for y in terms of x, then you can plug in the second formula and you can reduce the number of variables, right? Or if you are able to factor, like if you move all the terms on one side and you can get a factor of two things equal to 0, it means either A is 0 or B is 0. Then you gotta separate into cases. Okay? So this is how we solve system of nonlinear equations. So we will see different examples, and yeah, and then I will remind you the method. Okay, do you still remember example 1? We have the function, right? And we find the partial derivative with respect to x and y. And then we look at the first one. We realize, oh, x, yeah, x is power 1. We can solve for x in terms of y, and then we can plug in the second equation. We get equations of y only. Yes, everybody? Okay, let's see. Distribute. Right, so we distribute. 2 times 4y is, what is that? 2 times 4y is 8y. Plus 2 times y squared. Yes, everybody? Plus 4y times y is 4y squared. Yeah. And then plus y cubed. Is that okay, everybody? Mm-hmm. We order from the greatest power to the smaller power. Okay, the leading term is y cubed, right? And how many y squared? 6y squared. How many y? One, yeah, I mean 8y, right? Oh yeah. Yes. Okay. All right. See, we get a polynomial equation. You factor. Yes. So it's 2y squared plus 4y squared. Yeah, we combine them. Oh, okay. Attendance. Okay. Next week, I'll give you a new sheet. Okay. All right. Do you see a common factor here? Y. Yes. So we take out the y. We get y squared plus what? Plus 8. Good. Right, everybody? Can you factor further? So y and y, what multiply to get 8? 2 and 4, yes.
2, 4, 1, and 8.
Yeah, 2, 4, 1, and 8. If we try 2, 4, we multiply the outside, we get 4y. Yeah, we multiply the inside, we get 2y. When we add them, yes, we get 6y. So this is the correct factoring. Right, everybody? Okay, if you get factors of product of log of factor equal to 0, it means either the first factor is 0, or the second factor is 0, or the last factor equal to 0. Yes, everybody? So, okay. The second one. Yeah, -2. -4. Yes. So far, so good. Everybody? Yeah. We use the substitution method here. And then we solve for x in terms of y, plug in the second equation. And then we get a polynomial equation, right? So we factor completely, set each factor equal to 0. We get the 3 solutions about the y. We need to find the x. So what is x? Look at this. Solve for x. X is what? 4y plus y squared over 2. Yeah, everybody? Let's plug in. If y is 0, if you plug in y is 0, what do you get?
0.
Yes. 0 over 2 is 0. Good. How about when you plug in y is -2?
So that's 8, -8.
-8. -2 squared. 4 over 2. Ooh, what is that? Yeah, -2. So if y is -2, x is -2. Yes. How about when the y is -4? 4 times -4 is -16 plus -4 squared. 16. Oh, what happened? This is 0. Ah. Yes. So how many points are there? This is 0, 0. This is -2, -2. And what is the last point?
0.
-4, 0. What is your x? 0. Be careful. X is 0. Y is -4. Yes.
Oh.
Yeah. The first two, because they're the same number, so it doesn't matter the order. But the last one, they're different numbers. You have to put the x first. Okay, we have 3 points. Okay, so 3 points. Now we need to determine whether they are maximums or minimum. Do you still have enough space? Okay. Yep. We need to find the second derivative now. What is f(x)(x)? This is f(x). What's the derivative with respect to x?
The derivative, so
With respect to x.
x would be 2.
You mean
Or -2.
-2?
Yep.
Yeah, everybody. Oh, the y just like constant. So we f(x)(x) is -2. How about f(y)(y)? The derivative with respect to y. Fy with respect to y. What's the derivative of x? With respect to y.
Oh, 0.
0. And here,
2xy.
2xy derivative is 2x. Because derivative
Oh,
of
yeah,
y
yeah,
is 1.
that's right.
Yeah.
Yeah.
So that's 2x. Is everybody okay with that?
So we solved the polynomial, and then we're going to take the derivative.
Yes.
Okay.
Because you want to find whether they're local max, local mean. And in order to do that, you have to find all the second partial. And you compute the d. And you look at the d, whether it's positive or negative at that point to figure out whether it's local max, local mean, or saddle points. Okay, now fxy. We know it's the same as fyx. So let's do fxy. What's the derivative with respect to y? The derivative of 4y with respect to y? 4. And the derivative of y squared is 2y. The derivative of -2x? 0. Yes. So actually, you realize if we take the derivative of fy with respect to x, you also get 4 plus 2y. It's the same thing. Okay, wonderful. Now, let's look at those 3 points. So, okay, at 0, 0, what is, so fxx is always -2. And what is fyy when you plug in 0, 0? Yeah, x is 0. And how about fxy? 4. Yes, because the y is 0. So 4 plus 2 times 0 is 4. Is everybody okay? Mm-hmm. All right, we're ready. We plug in D. So D is, yeah, everybody memorize it. Fxx times fyy minus square. Yep. Fxx, -2 times fyy, 0 minus 4 squared. What is that? -16. Do you see it's negative? Mm-hmm. So what is the conclusion if D is negative? Saddle point. So this is the saddle point. Yep. Everybody okay with that? Now we continue. Next point is -2, -2. Okay. Fxx is always the same as -2. Okay, let me ask you, so you answer me. Definitely, what is fyy? So fyy, you plug in x is -2, then what do you get? Yeah, -4. Mm-hmm. All right. How about fxy? Gabby. We put -4 here. That's right, -2 here. Yeah. Do you see we get 0, everybody? So fxy is 0. Our D is fxx, fyy minus fxy squared. -2 times -4 minus 0 squared. What is that? Okay. Yes, 8. And 8 is positive. Mm-hmm. So D is positive. Fxx is negative. That means it's concave down. Yeah? Negative concave down. Then what is that? Local max. Exactly. So the -2, this point is a local max. Okay. All right, the last one. 0 and -4. Let's see. Morgan. Fxx is. Can you also tell me fyy? Yes, good. Okay. And fxy. Sarah. What is fxy? So will be 4. Yeah, 4 and then plus 2 times -4. So it's 4 minus 8. It's -4. Right, everybody? D. So if you get used to the D is, you know, it's fxx times fyy minus x squared, and you don't have to copy the formula. Okay, so x is what? Negative 2 fyy is 0 minus fxy, negative 4 squared. What is your answer?
Or 16. Right?
Yeah, negative 16. Oh, it's negative. What do you say? This point is yeah, it's a saddle point.
So then it goes like this, right? Can you graph it for me? Can you
Okay,
show it?
sure. Yep. So we can look at the picture. And oops, sorry. I get two. So 4xy. The algebra. And we need 3D. So z equals 4xy. And then what? Xy squared. And then minus z squared. Okay, so let's see here. Do you see that point here? It's local max.
Yeah.
And then this point and this point is a saddle point because this side is the minimum, but that side is the maximum. So if you look like this, yep. It's a saddle point. Yes. Okay. Good. Wonderful. So yes, that check our answers. We're doing okay. Right. So the process. What's the process? First step, you find the first derivatives. It's set them equal to 0. And you get a system of a nonlinear equation. So you either use substitution method or I realized that my notes, I actually use a different method. Okay, let's look at my different methods here. So solving system of equations, there could be more than one way to do that. Okay, maybe some way is easier, some way is harder. You don't know. Okay, so look at this. What I did is I look at the second equation, and I realized I can factor out a 2x, right? And then you see a product of 2 factor equal to 0. It means either 2x is 0 or the 2 plus y is 0, right? So if you see either or, it means you separate into cases. So there are two cases. Either x is 0. So if you have x is 0, you plug in the first equation, and then you get 4y plus y squared is 0. You can factor out a y. You get y is either 0 or negative 4. So you get those 2 points. Or second case, if y is negative 2, plug in the first equation and you solve for x. So you see you get x is negative 2. So you get the 3 solutions as well. But we're using different methods. So in class, we use substitution method. And then the notes here, I was using factor one of the equation and separate into cases. Those two methods are the most common method to solve system of nonlinear equations. Okay. All right. Oh, by the way, this symbol, it just means determinant. You know that it means fx times fyy minus fxy squared. Okay. All right. Let's continue. Okay, story problem. Yeah, applications. We love applications. So, a company is developing a new soft drink. The cost in dollars to produce a batch of the drink is approximated by the following. Where X is the number of kilograms of sugar per batch, and Y is the number of grams of fairing per batch. Find the amount of sugar and fairing that results in the minimum cost. And what is the minimum cost? Okay, so we have a function of two variables, and we want to find the minimum. Yes. Okay, let's do that. Story problem, usually the number are like bigger. Okay, so let's see. All right. So step 1, we find the first derivatives. So what's the derivative with respect to x? Hi, Paige. What's the derivative with respect to x? Derivative of 2200 is 0. And 27x cubed is 27 stays here, right? What's the derivative of x cubed?
The derivative of x cubed is
Yeah, 3x squared. And then the derivative of 72xy is, yeah, 72y. And then the derivative of 8y squared is 0, right?
Yeah,
Because
it's a constant.
Yeah, it's
Okay.
constant. Good. Yes. Yeah, sure. If you know that, you can do it together. And what is 27 times 3? Yeah, 81. Yes. Okay, and then the derivative is back to y. Well, this is derivative is back to y. 0 here. Respect to y.
Oh, 0.
Yes. And here?
72.
Yes. You mean?
72.
Yeah, negative 72x. And then plus? Yes, good. Okay, we set them equal to 0 to find the critical point. So we solve the system of nonlinear equations. Okay, let's see which one is easier. Looks like we can solve for y in terms of x. Right? Anybody? Okay, so we call this is equation 1, equation 2. Let's add 72x on both sides. We get 16y is 72x. How do you solve for y? Yeah, divided by 16. So y equals, okay, what's the can we simplify it? 72 is 8 times what? 9. 16 is 8 times 2. Oh, so this is 9 over 2x. Right, everybody? Okay, good. So we solve for y in terms of x. Then we can plug in equation 1. Let's see. We get 81x squared minus 72y. Y is 9 over 2x. Right, everybody?
Oh, okay, yeah.
72 and 2. We can cancel. We get what? 36. Yep. Everybody? What's the common factor? Oh, by the way, very, very important. When you solve for equations, you can only divide by number. Do not divide by a variable because you may lose some solution.
Can you separate the x out?
Yeah, we factor. Exactly. Do not divide it by x. We factor the x. Okay?
And then you don't lose the solution.
Yeah. In that case, we don't lose solution. And besides x, can you see 81 is also a common factor? Because you have 9 and 36 is 9 times 4. Yeah. We factor out 81x. And then what's left? 82x squared. We factor out 81x. What's left? X. X minus. What's left?
36.
36 is 9 times 4, right? The 9 and the 9 and the x. Yeah. We factor that out, so the 4 is left. Right, everybody? Right, the 9 and the 9 and the x, we factor that out. That's 81x. So what's left is the 4. The common factor. You can think of this as like 4.
Why can't you just pull 9 out? Why would you
36 times 9 and then you divide that by 81?
Yeah. You can, because you can think of that as like 81, 4 times 81x. We factor out the 81x. What's left is the 4.
Would it be? So could you actually just pull 9 out instead and put it in front?
Oh yeah, you can put 9 out, and you can put 9x out. Then you get 9 minus 36.
Okay. Yeah.
And then you put another 9 out.
Okay.
Yeah.
Okay. Now it makes more sense.
Right. So yeah. Okay. All right. So next we let x is 0 or x minus 4 is 0. That x equals what? 4. Yep. Okay. Now look at the y. So that's the y. If x is 0, we plug in x is 0. What is the y?
0.
0. Yeah. Okay, if x is 4, what is the y? 18. Very good. So y is 18. Okay, the solution. So put them in the point form. This is 0, 0. And this one is 4, 18. Yes. So make sure when you put the point form, okay, which one is x? X is 4. And the y is 18. Remember our last example, your x and y switch? Yes. Okay, good. That is the solution of the system of nonlinear equations. Now, what do we do?
Of the fx, x,
Yes,
y, fx,
exactly. So, because the function is c, cxx is what? Plane? With respect to x. Yes, 2 times that is
160.
yes. And then the derivative of this with respect to x is
0.
exactly. Good. CYY. Patrick, what's the derivative with respect to y?
16.
Yes, it's just 16 because this is like a constant, so it's 0. And then it's 16. Yeah. Okay, CXY. Bethany? What's the derivative of CX with respect to y? With respect to y. So the derivative of this with respect to y is 0. This exactly negative 72. Right, everybody? We have 2 points that we need to plug in. So let's say at the point 0, 0, our CXX is what? 0. Okay. And because our CYY, CXY, they're just constant, and can we not copy it down? Yeah. And we compute the D. D is the CXX, CYY minus the CXY squared. Are you okay with the D formula? Okay. CXX is 0. CYY 16 minus negative 72 squared. What happened? We get negative 72 squared. Because it's negative squared, it cancels, become positive. So it's negative of the 72 squared. The answer is.
So you want to distribute the negative first?
Oh, we can. It's like the square first.
Okay.
So
Oh yeah,
it's
that's right.
like
'cause
three
order
negative.
operation. Yeah.
Three negative here, so it becomes negative. Yeah. So it's less than 0. If D is less than 0, what do you say? Saddle point. Okay. So 0, 0 is a saddle point. Now at 418, what is CXX? 162 times 4, right? Actually, I don't really need to calculate what it is. I just need to know it's greater than 0, right? Okay, and the D is. Can I not write down the formula again? Can I just type in? So I got CXX 162 times 4 times CYY. What is CYY? 16. And then minus negative 72 squared. Okay, I need your help. So put this in your calculator. By the way, you don't need to put the negative. You can just put 72 squared. And then what do you get?
Negative 4,536.
Okay, like this. Thank you.
Let's look at that one.
Oh, so okay. Let's see. Let's try again.
I got 15,500.
Okay. Something wrong with my word. Let me save it. Hey. Okay. So 5,000. What? 100.
Oh,
Thank you. That's positive. Right, everybody? So, okay, look at this. If D is positive and FXX is positive, we have concave up. Right, concave up. What do you say? This is a local minimum. Right? And the problem asks us to find the minimum. So this makes sense, right? Okay, what is the minimum cost? The minimum cost is we plug into the original function. Yeah, so 418. So we plug in the original function with x is 4 and the y is 18. Okay, so 2200 plus 27, x is 4. So 4 cubed minus what?
22 times 4 times.
Plus 8 times. Yes. Okay, so put this in your calculator. And what do you get? What number do you get?
I got 1336.
1336. Thank you. Yes, so that is our minimum cost. So everybody clear about the process? Yep. Okay. So we get 9 minutes left. We have 2 examples. Do you mind to watch the solution with me instead of working on those examples? Because we're behind schedule, so we might, if we want to like squeeze time, we either like do less problems, but if we still want to do more problems, can we just look at the solution together? Okay, and go over the idea. Yeah. Okay, let's do that. So we find the local maximum, minimum, and center points for this problem. So first we find the first partial derivatives, right? Derivative with respect to x, 3x squared. Derivative with respect to x, 0, right? Derivative with respect to x, 6x. So how about, don't take notes right now. Okay, we look at the solution pretty quick. And then when you get home, try those problems on your own and see if you can solve it again. Okay, let's do that. Derivative of 3x squared, 6x. And then the y with respect to x squared is just constant, 0. And then the derivative with respect to y, this term is 0. This term, 3y squared. This term, 0. This term, 8. This is, negative 6. Right? And this term, 0. Right? Okay, we get the first partial derivatives. We set them equal to 0. We look at, so in this case, we can look at, the only, this is functions, equations about x only. This is equations about y only. So we can solve for x. We look at the common factor is 3x, right? We factor out 3x, what's left? X plus 2. Yes, everybody? And we set each factor equal to 0. So either x is 0 or x plus 2 is 0, and x is negative 2. Okay, so we get 2 numbers for x. And then the y, we factor out the 3y. We get, what's left? Y minus 2. Okay? So either y is 0 or y is 2.
So flip.
Yes. Okay, but how many combinations are there? You can take 0, 0, 0, 2, or negative 2, 0, negative 2, and 2. So we actually get 4 points. And the second derivative with respect to x is 6x plus 6. Derivative with respect to y, 6y minus 6. Derivative with respect to y, no y here, so 0. Okay? So at 0, 0, at xx, you see, x is 0, y is 0. You get 6 times negative 6 and minus 0. 6 times negative 6, negative 36. Right? So D is negative, is a set of points. Okay? And how about negative 2, 0? X is negative 2, so 6 times negative 2 is negative 12. Plus 6, negative 6. So negative 6 times y is 0, so still negative 6. And then fxy is 0. You get D is 36 positive, and fxx is negative. So it's counted down. That is the local max. Right? And 0, 2.
Okay, so you do the negative 6, you'll take that first so that you know it's going down.
Yes.
Multiply. Okay,
Right.
I'm just making sure because I might skip that on accident.
Oh, so that's why the rule is if D is positive, fxx and fyy, they're of the same sign. Yes. So if one of them is positive, the other one must be positive. So you're concave up in all directions. So it's local minimum. If one of them is negative, the other one must be negative because the D is positive. They're the same sign. So in all directions, concave down is a local maximum. Yeah. Good. Okay. Yep. So in this case, the x is 0, right? We get 6. And y is 2. So 12 minus 6. It's also 6. So D is positive. Fxx is positive. The concave up, we get a local minimum. Right, everybody? And negative 2, 2. We get the D is negative. It's a set of points. Do you want to look at the graph of this function?
Sure.
Yeah. So let's see. Okay, so GeoGebra, where are you? Okay, so we don't draw this. Let's do this one. X cube plus y cube and plus 3x squared and then minus 3y squared and then minus 8. Ooh. Okay, you gotta string this. Okay, let's see. We have a point here. Let's see. Where's is it? Okay.
It's
That? Yeah, it looks.
not a flat plane, but it's basically a flat plane with bumps.
Yeah. So we have a local max and local mean there, and the other point saddle point. Okay, everybody. Okay, and then 3 minutes. Okay, let's look at this one pretty quick. All right. So the company makes 2 products. The demand function for the 2 products are given below. And P1, P2, and Q1, Q2 are the P is the prices, and Q is the quantity of the products. Find the price the company should charge for each product in order to maximize the total revenue. So revenue is price times quantity, right, everybody? So you have a homework problem like this. Price times quantity. So you get P1 times Q1, and then P2 times Q2. And I don't like P1, P2, so I changed to X and Y. Do you like P1, P2? No, right? You change to X, Y. Then you get a function like this, right? And then similar process, you find the first derivatives and set them equals to each other. Oh, it turns out they are linear equations, right? You know how to solve linear equations. You can use elimination method or substitution methods. And once you get the solution, I get a single point. And then you can plug in find the second partial derivatives and then compute the D. Because D is positive and do you see all these numbers are constants? Yeah. So we get our Rxx negative, so it's concave down. So this is the maximum. So we get the maximum value at the point 25, 25. And what is the maximum value? You plug in the R, and then you get this number. So do you understand the idea? So you have a homework problem like this. So just change the numbers. Okay? Good. Next class, we will study 9.4. Have a good day. And I will hope to see you more often in my office hours. Bye.
Bye-bye. I'll see you on Wednesday and Friday.
Okay, sounds
I
good.
have to go pick up plants off my porch before they die.
Yep. Bye.
You said 11 to 1:30, right?
Yes.